as per relative speed concept. This relative speed is applicable only when two objects are moving. At a time, we can apply only two objects are moving. So if only one object is moving, you cannot, no need of this relative speed concept. Only two objects are moving, then only we need relative speed concept. If that object speed are s1 and s2, okay, speed should be added if it is opposite direction. I'll let you know why. We'll give one basic example. Then your lifelong you can remember why we had to add in opposite direction and why we are subtracting in same direction. Only for two objects at a time. So three objects are there. If suppose three are moving, we can apply for two at a time. We cannot apply for three at a time. We can apply for two at a time only. Relative speed cannot be applied for three objects at a time. Only for two. Okay. So why we have to add? First point is why we need to add. Okay, in opposite direction. Why we need to subtract in opposite direction? My dear friend, listen. Okay, let's say you are traveling from Hyderabad to Madras. Okay, around 1,800 kilometers. Let us say Hyderabad to Chennai. You are traveling. Okay, 800 kilometers. One person is moving from Hyderabad to Madras. Other person Madras to Hyderabad. Opposite direction. Okay. Now, if okay, Hyderabad to Madras, Madras to opposite direction. Fine. That's one situation. Or maybe for 800 kilometers, you may think bigger. 60 kilometers. Fine. I'll put it 60 kilometer. A and B. One person is moving from A to B, another person B to A. The other case is same direction, okay? A to B, 60 kilometers. This one is moving. Train, okay. Car 1, car 2 better. Car 1 and car 2. Here also car 1 and car 2. Guys, in these two situations, see, in first one, is it taking less time to meet or more time to meet? First situation, opposite direction. One person moving from A to B, another person moving from B to A. They'll take less time or more time to meet. Less time taken. Okay, because both are adding towards each other, traveling towards each other practically if you think. Then when you go for this second case, first thing here, C2 must be greater than C1. Speed of second car must be greater than first car. Then only chasing. This is like chasing. So first person is chased by second person. Second person is chasing first person. Okay, so now C2 must be more than C1 and there is 60. This guy, okay, C2 speed is more than C1 and keep traveling later. Long after a lot of time, they are going to meet. Distance between them is 60 only. Both cases, distance is 60. Distance is constant. Here, less time taken to meet, whereas it will take more time. It will take more time to meet. So, time speed is inversely proportional to timing. In opposite direction, you are taking less time. That means speed should be more. Adding. In same direction, you are taking more time to be practical. Also, you can check when both are traveling. This one should overtake that. How much extra? That only will get advantage, and you can go and meet it. Will take more time if both are traveling in same direction. Already you are 60 kilometers ahead of me, and you are traveling. I am also traveling the same direction. Coming and meeting that, overtaking that 60 kilometers will take more time to meet the second car and first car. So here speeds will be less because time is more, speed will be less. Time and speed are inversely proportional. Distance is constant in both the cases. So speeds will be added in opposite, speeds will be subtracted in same direction. The basic reason is this example. Less time taken, more time taken. Right? Now this question, that is why you can see gap here is 120. I give an example 60. Here gap is 120 and opposite direction will take only 1 hour to meet, same direction 6 hours to meet. Both the cases distance is 120 only. So here distance 120. 120 kilometers distance. Speed is P car plus Q car. Timing is 1 hour. Distance is speed into time. 120 kilometers speed SP plus SQ into 1 because they will meet in 1 hour. Whereas second case distance 120. Speeds are, it can be SP minus SQ or it can be SQ minus SP also. Which is more, which is less, they have to mention. If not, we'll go as per the order SP minus SQ into 6 hours. This is 20. Right. Yeah. 70 is the answer. Adding those two divided by 2. Add these two equations. SQ will cancel. 2SP equal to 140. SP equal to 70. Relative speed, basic question. Speeds must be added. If it is opposite direction, speeds are subtracted in same direction. Distance is constant in both the cases. Distance is speed into time. Relative speed concept will come into picture if two objects are in motion, two objects are moving. So this question, what is your answer? Two trains started at 7 a.m. from the same point. The first train traveled north at a speed of 80 and second train traveled south at a speed of 100. The time at which they were 40 kilometers. Two trains started at 7 a.m. from the same point. Relative speed related question with relative speed concept. Sir, 3 hours. Then answer will be 10 a.m. Answer is 10 a.m. Good. North and south means opposite. Both started at 7 a.m. One train is moving towards north, another train moving towards south. 7 a.m. both trains are at the same point. One traveling towards north, one with towards south. So opposite direction. They're asking timing. Timing is distance by speed. Here relative speed I had to mention. Distance is how much? 540. Speeds we should add or subtract. Add as they are in opposite direction. So 540 divided by 180, we'll get it like 3 hours. Timing is 3 hours from 7 a.m. They're asking in terms of timing. So from 7 a.m. 3 hours. 10 a.m. must be your answer. 10 a.m. the distance between the trains will be 540 kilometers. Same direction, opposite direction. This is opposite direction. Next question you can see same direction one. Think this question is given in GATE. Very easy one given in GATE. Next question also very easy question given in GATE exam. That I removed good at least. Fine, so relative speed okay, but before going for next question, let me give you the basic related to problems on trains as well. Trains, problems on trains. Already with respect to speed, you have a clarity. With respect to speed, you have a clarity. Now with respect to distance, with respect to distance. See, time is distance by speed. Timing, nothing can be changed. They'll give in the question or we have to calculate. Only parameter is distance and speed. If suppose only one object is moving, we have to consider speed. If two objects are moving, we have to consider. If two objects are moving, we have to consider relative speed. If only one object is moving, then we have to see only that one speed. Okay. Now, why I mentioned is, let's say in this problems and trains concept, train is crossing a pole. When train is crossing a pole, what should be the speed? I'll give you all those examples. Like, okay, I'm focusing on speed parameter now. When train is crossing, when train crossing stationary objects, when train is crossing stationary objects. What are the stationary objects, sir? Train is crossing a pole. Train is crossing a man standing. Man means generally man or woman, okay, whatever it may be, living being, it's we can have to consider it's a moving. But that's why they are mentioning clearly man standing. If man standing or sitting, then it's a stationary object. Speed is zero. Stationary object here, in the sense, speed of that object is zero. When train crossing a pole, tree, when train crossing a bridge, when train crossing a platform, when train crossing a man standing or man sitting, when train is crossing stationary train means which is at stop. When due to crossing, they'll hold one way one train okay, on the track. So stationary train, which is not moving. So in all these cases, speed must be equal to speed of the train only because only train is moving. In all these cases, when train crossing, tree, pole, man standing or sitting, train crossing a platform, train crossing a bridge, train crossing stationary train, in all these cases, we should consider speed is nothing but speed of the train. Okay, because only train is moving. Next scenario, again speed only, speed related. Now train crossing moving objects. When train crossing moving objects, when train is crossing moving objects, then we should focus. We should take speed is nothing but equal to relative speed now. Again, it will be plus or minus, depends on opposite direction means plus, same direction means minus. So train crossing moving objects means what? Train is crossing a man running, man moving. In question they'll say a train is crossing a man who is moving. Train is crossing another train. Train is crossing another train. Train is crossing a man running or moving or a man who is doing jogging. Train crossing a jogger. There is one question like that also. Train crossing a jogger, a person who is doing jogging. Right? So in all these cases, speed must be equal to relative speed. Then train speed plus object speed or train speed minus object speed we have to decide depends on the situation. It's not fixed. We should decide depends on situation. Right. This is about when train crossing moving objects. Speed parameter is clear. Next, I need to focus on distance. Then time is distance by speed. We can calculate timing. That's it. All questions. That's what the basic idea. Next is regarding distance. So what about this distance parameter? Distance point of view. First one, train crossing an object with negligible length. What is this, sir? Train crossing an object with negligible length. With negligible length. This is actually compared to trained here. This negligible length word is with respect to train length. When compared to train length, that object length is negligible. So what are those examples? Train, all these cases, train crossing an object, object with negligible length is, see, compared to train length, which might be 1 kilometer length also, 1000 meters, 800 meters, 900 meters length. Compared to train length, man length is negligible, tree length is negligible, pole length is negligible. If a train crossing a man or pole or tree, man standing or sitting or running or walking, whatever it may be. In all these cases, if the question is like train crossing a man, distance will be length of the train only. Train crossing a pole, distance will be length of the train only. Provided, okay, let's say pole is here, or tree is here, or man is here. In general, question they're asking, train crossing a pole means the man means by default will say train is exactly here. Now train should cross this person. There are some special cases. Man will be somewhere, train will be somewhere, 1 kilometer distance. Now train should cross. That means 1 kilometer plus train length will come. I'm telling you, there is situation may be like this. See, man is here, train is here. There is some distance between them. Then if that is the case, the distance between the man and train plus train length will come into picture. In general, train crossing the pole, train crossing the man means train is exactly there. Now this is the front of the train. This back of train should come here. But that's what's the time taken. That front of the train cross, back of the train should be here. This front will go, back should be here. Means that's nothing but length of the train only. Okay, this is, let's say this is pole. This train should cross this. Before crossing, this is the situation. After crossing, this is the situation. For this, what is the time taken? Here, front of the train. This is back of the train. Front, back. So that's what length of the train in all these cases. Man running or walking or jogging. Okay, so all these cases we should consider only distance is length of the train. Second case, train crossing an object. An object with length. Here length is not negligible, with length. Train is crossing an object with length. Previously negligible length. Now this is having certain length, object with length. So what are the examples, sir? Train is crossing another train. Whether it is at stopping or moving, my dear friend, listen. By default, if they mention train is moving only, we should consider. Until unless they mention stationary. By default, man also should be considered as a moving object until unless they said man sitting, standing, something like that. Okay, so here train is crossing moving train, another moving train, this train is crossing stationary train also. Other train length is not negligible compared to this train length. So we should consider length of that. And train is crossing platform. We know platform length is more than the train length. Train is crossing the bridge. Train is crossing bridge, train is crossing a platform, train is crossing another train. In these type of examples, distance must be equal to length of the train plus length of the object. Let's say here we have a bridge. This is bridge. Now train crossing the bridge means we'll consider train is here. Train is here. Now it should cross the bridge. Means what is the outcome we are expecting is here bridge will be here, train should leave this, and okay, this should be the situation. Now train is here, now train should cross and okay, move out of that. Here train should, this for this first see, practically if we go ahead, now let's say this is the bridge, we can consider this is the bridge, right? So now bridge, this train first cover the bridge length, then it should cross. This is length of the train. Now first covering the bridge length, LB object length plus it's crossing that train length. LB plus LT. Instead of LB we call length of the object. Train length plus object length. So that's what these four parameters we can handle any question related to problems on trains. Different combinations they'll give. Provided again provided again this is in a situation two trains are the same place. Generally train crossing and the train is both trains fronts are at the same place or back of the first train and front of the second train will be the same place. No sir, there is 100 kilometers distance between the train, then they'll mention that. Question లో 100 kilometers distance ఉంటే వాళ్ళు చెప్తారు. చెప్పలేదు ట్రైన్ క్రాసింగ్ అందర్ ట్రైన్ అంటే వీల్ కన్సిడర్ both trains are fronts are at the same place or first one back side second one front side will be at the same place, we should consider. Means I want to convey trains case lo both will be like this. So first train, this is chasing same direction, they say train 1 crossing train 2, train 1 crossing train, this is one situation or else this is the other situation. Opposite direction means yeah, in different track, in different tracks, this is opposite direction situation, train 1 train 2. If it is same direction train 1, there is no distance between them, between them. Okay, second first train ending second train starting or first train starting second train starting, both will be the same. This is opposite direction means this should come into your picture. If it is same direction, this one should come into picture. Now in these two cases, my dear friend, let me know what will be the distance, what will be the speed. I am giving you notation like this is train 1 length is L1, train 2 length is L2, train 1 speed is S1, train 2 speed is S2, train 1 speed is S1, train 2 speed is S2. Now, what is the relation between the distance, speed and time here? What is distance? What is speed? What should be time in this case? Distance, speed and time. When train is crossing another train in same direction, timing anyhow you need to calculate, that won't be disturbed much. Distance and speed at least. What will be speed here, sir? Chasing, which one should be more? What should be the speed here? Two objects are moving or one only moving? Then speed must be relative speed, okay. Now, as I mentioned, same direction, speeds must be subtracted. Is it S1 minus S2 or S2 minus S1? Second one chasing first one, second one speed must be. What about this one, opposite direction? Added. Okay, great. What about distance? Train is crossing a platform, train is crossing a bridge. Here train is crossing another train, same. Length of train 1 plus length of train 2. Just now we discussed train crossing the bridge. Instead of bridge, there is another train. If you want to understand better, both moving, you may not get the clarity. Freeze this first train. Second train, it should cover this first train length. Then it should cross second train length. When it is opposite direction or same direction, when both are moving, you cannot assume distance properly. Freeze one thing. Already speed I mentioned S1 plus S2 or S1 minus S2. Now freeze this. First it is covering this. So this one length, this is train 1 means train 1 length. Then it's crossing train 2 length. So distance must be L1 plus L2 in both the cases. Second case, don't say L1 minus L2, sir. Here also L1 plus L2 only. Both cases L1 plus L2 only, but what's the difference is speed. Opposite direction speeds are added, same direction speeds must be subtracted. This question they given. A train requires 7 seconds to pass a pole, while it requires 25 seconds to cross a stationary train which is 378 meters long. Now question is regarding find the speed of the train. So there are two situations. First one is train crossing a pole. Second situation, train is crossing a stationary train. So I want D1 S1 T1, D2 S2 T2. Yeah, this D1 is related to pole. Train is crossing the pole. Next one, train is crossing stationary train. Two situations. So I want DST in both cases. Stationary train D2 S2 D2 T2. Sorry. Three parameters I want in both cases. Train crossing pole. Guys, when train is crossing pole, what is the distance? Distance must be Pole length is negligible compared to train length. So we can say length of the train. Right, so length of the train. What about speed? Train crossing pole. Pole and train both are moving objects. No, only train. So speed must be speed of the train. What's the time taken to do that? 7 seconds. Okay. Next, the train is crossing stationary train. In this, what is the speed? Train crossing stationary train, which is moving object. Only one train, and the train is stationary. So speed of the train only. Time taken 25 seconds. Distance, length of the train plus length of train, which is 378. Object length agreed, which is 378 meters as per the question. Right? You know, listen, distance is speed into time, or maybe speed is constant. I said, okay, in the introduction, we discussed certain questions. Time is constant, distance is constant. Now, this is a situation where speed is constant. When speed is constant, what's the relation between distance and timing? Distance, speed is constant here. Speed is constant in this case. So, when speed is constant, we can say distance and timing are directly related. So distance and timing both are related. I can say D1 divided by D2 equal to T1 divided by T2. In D1, length of the train, in D2, length of the train plus 378 equal to 7 divided by 25. Now cross multiplying and you can calculate length of the train. Then we know D1 equal to S1 T1. We can have 7ST. Different ways. This is one method. You can calculate length of the train from here. And then length of the train is 7 times the speed of the train. Then you can calculate speed of the train. This is lot of disturbance in this doing all. But my logic is very simple. Listen, this is all the procedure what you can follow, but our logic is very simple. See, same train, both cases same train. First case taking 7 seconds, next case it is taking, what is the extra time, sir? How much extra? 18 seconds it is traveled extra. Okay, what distance it is traveled extra in that? Now listen, you can solve this question very simple like this. Train travel 378 meters extra in extra 18 seconds. So I can write speed of the train directly 378 divided by 80, which is 21 meters per second. Sir, how can you write like that? See, same train, extra distance travel 378, extra time taken 18 seconds. So 378 meters covered in 18 seconds. So 21 meters per second. It is meters per second. We need to convert that into kilometer per hour. Have a look. A lot of people may go with option D as you got 21, but here problem is we need kilometer per hour. We got meter per second. So what's the conversion we can do? 18 by 15 or 3.6. 21 into 3.6, or we can say 18 divided by. So what you got the answer? 75.6. This is direct method. Okay, where same train, extra distance 378, extra timing 18 seconds. Very good. Whereas the other side of the coin, we given, okay sir, no, I am not getting this clue in exam. No problem. Two equations, two unknowns. LTST, LTST, two unknowns. We have two equations. D equal to S into T, distance is speed into time. Using that, we'll get two equations, two unknowns. Solve. Okay, you solve in any way. Two equations, two unknowns, that's it. So what I'm doing is distance, if speed is constant in this question, I use distance is directly proportional to timing. From that we calculate length of the train, and length of the train is 7 times the speed of the train. Then we can calculate speed of the train as 21. So we need to go long way, calculating length of the train, then speed of the train. This is what the process, right? Okay, or else the other method is d equal to s into t. I think instead of going for speed is constant, I think directly we will get length of the train is 7 times speed of the train. Here length of the train plus 378 equal to 25 st. I think here you people can get speed of the train directly. LT you can put it here. We can calculate speed of the train directly. We'll get 21. Distance is speed into time. Distance is speed into time. D1 equal to S1 T1. D2 equal to S2 T2. Substitute LT as ST in terms of ST. Then we can calculate speed of the train is 21. Then convert that into kilometer per hour. Right. So that's first question. Train is crossing pole. Train is crossing stationary train. Now see the second question related to problems on trains. The train takes 10 seconds to cross a man standing on the platform. Now, very important is this term, my dear friend. There are two situations. Man standing on the platform. Next one, 44 seconds to cross the platform. Guys, first case, can anyone tell what's the distance, speed and time? First one, D1, S1, T1. Next one, D2 is there. This is routine. In this concept, problems on trains. Okay, there are two cases in this one, man standing on platform, train crossing, man standing on platform. Next one, train is crossing platform. So two situations we need to note down. What is the distance, what is the speed, what is the timing. So what is the distance here, D1? D1 is what, S1 is what, T1 is what? At least S1, T1 I think you know 10 seconds to cross man standing on platform. T2, 44 seconds. Superb. Question given speed of the train directly 72 kilometer per hour, but distance is in meters, timing is in seconds. It's your job. We need to convert into meter per second. So previous question you did reverse, but here the need of the hour in question the terms are meters and seconds. Speed also should be in meters and seconds. That's what. Speed is 20 meters per second. Now timing fine. I want distance and speed. What is the speed in first case? Train crossing a man standing on platform. Is platform stationary? Man standing stationary? Only which is moving here? Train. So train speed is 20. Second case, train crossing platforms here. What is the speed? Train crossing platform. Train crossing platform. So speed is nothing but 20 meters per second because platform is stationary, only train is moving. Right? So fine. Now what about distance? Train crossing a man standing on platform. First of all, train crossing the platform. What is the distance train crossing platform? Train crossing platform distance. Length of the train plus length of the platform. What about man standing on platform? Only length of the train because train crossing man only. They just want to confuse you people. In some questions, what they'll do, no platform length will be given. Okay, they'll give train length. They'll ask you what is the time taken to cross the man standing on platform. Many people, there are some shortcuts also in YouTube. People will say, what are the distances that add it? In this topic, it's not like that. If they given platform length also, don't add it. If it is man standing on platform, if wanted they give train length and platform, then don't add both. For train crossing, man standing on platform, man standing on road, man standing on bridge, man standing in train also same case. Listen, there is a next level question like a man in train one observes train to cross in 10 seconds. That's listen to this statement. A man sitting in train one, a man sitting in a train observes another train crosses in 10 seconds. A man in train observes that another train crosses him in 10 seconds. Now in this situation, can you say what is the distance? What is the speed? What is the timing? Distance, speed, and timing. Timing is mention opposite or same direction, okay, but relative speed will come into picture. This person is a train, another train. Both are moving. They not mention anything called stationary. The man sitting in train observes another train crosses him in 10 seconds. Speed must be relative speed. It is opposite direction, same direction, subtract. But important is distance. What is the distance? Which train? Let's say man sitting in train 1. Okay, another train is train 2. Which train length I have to consider? Both. You have to consider L2, length of train 2, not person sitting. Now, in this situation, in this question, what you are telling, man is standing on platform. You are not considering platform length. We are crossing only man. Man is on platform, on road. We don't do anything. Train is crossing only man. Similarly, a man is in train 1. Train 2 crosses him in 10 seconds. Means only train 2 length. Man, this train 1 length not required. Man is in which train? That length is not required. Another train length only we require. What's the point? So that's what we understand the situation. I didn't wantedly discuss separately. Initially, I said, okay, train crossing object with length with negligible length, as simple as, right? So here, okay, good. Now, what is the question about? What is the question they're asking? What do you want? Only length of here to here. What is the extra distance? Platform. Here extra timing. So in 34 seconds, what is the distance traveled by the train? Is nothing but platform length. Don't calculate length of the train in first one. D1 equal to S1 T1, sir. Length of the train is 20 into 10, 100, 200, sir. Then here also D2 equal to S3 T2. No need. Extra distance is platform length. Extra time taken is 34 seconds. In the 34 seconds, what is the distance traveled by the train? 34 into 20, which is nothing but 680 meters. Sir, you are not calculating length of the train. They not ask that one, right? Why I have to waste my time in exam? Okay, the extra time 34 seconds. That is to travel that cover the platform length. So 34 seconds, whatever the distance covered by train. Train is traveling with 20 meters per second. Train is traveling with 20 meters per second. 20 timing speed is 20, time is 34. This will give 680 meters. That's what option C. Option C, 680 meters. Got it? See the next question. I'll share you the document, don't worry. Focus on how to solve the question. This is now same question. Values, everything is mentioned. Calculate, please. One is train running, crosses a bridge in 30 seconds. Then a man on the bridge, pretty much similar to that previous question. So first one is length of the train plus length of the bridge. Distance is speed into timing, which is 1200. Next one, train crosses a man on the bridge. So here length of the train only will come into picture as they clearly mentioned all. So we got this is 400. Adding together 1200, other one should be 800. So see the fourth question now. It's almost similar to previous one. This question is okay. I just want to specify that. See, in a placement's point of view, previous question okay. This question is given in gate. I need to mention that because in gate, every question will be in detail. See, when train crossing a platform, you may have a doubt how it is, what is that. Here they clearly mention. From that time, the front of the train crosses, it takes 25 seconds to the back of the train to leave the platform. Whatever we say, they clearly mention it. They can simply write time taken by the train to cross platform is 25 seconds is sufficient. But they're giving in detail. Gate exam and TCS, both they'll give every question in detail. That is why it maybe looks like lengthy, but they want to give clarity in the question. Don't feel question length is bigger, question is difficult, I don't solve. Don't be in that style. Okay, they'll give questions bit lengthy to give everything in detail. Everything in detail. Now here train crossing platform, simple. Next one train crossing a man running, right? So whatever we discussed that introduction related to four cases. Okay, train crossing a man, okay, object with length with negligible length, train crossing stationary object, train crossing moving object. All four will cover in this one question. So first one, train crossing a platform. Okay, platform. Now what is distance? What is speed? What is timing? Speed. Yeah, what is the speed, sir? Speed is nothing but speed of the train. And here it is 54 kilometer per hour. It's your job. You need to convert that to meter per second because options. This is in meter. Timing is in second. So we have to convert that kilometer per hour to meter per second. So train crossing platform means speed is nothing but speed of the train. So 54 into 5 by 18, 3 into 5, 15 meters per second. And they mention what is the time taken is? Time taken is given 25 seconds. Distance is what to be written? Platform. Train crossing platform. Distance must be length of the train plus length of the platform. Super. Next one, train crossing a man running. How much time it is taken? 14 seconds if I am not wrong. So is it 14? Yeah, fine. So a train crossing a man running. Guys, now what is the distance? Distance is length of the train. Train crossing a man, distance is length of the train. Speed. Now we want man running, train running. Now same direction or opposite direction is required. What they mentioned in question? Same direction is already mentioned. So speeds must be subtracted 54 minus 9, which is 45 kilometer per hour, but still we are doing into 5 by 18 to convert into meters per second. Now question, if you observe, the question is regarding length of the train and length of the platform. All options length of the train is different. If you calculate length of the train, then you are done with the question. Okay, we'll calculate platform also fine. But in this question, length of the train is sufficient to address what is the right option. So D2 equal to S2 into T2. D2 equal to S2 into T2. D2 is length of the train. S2 is nothing but 45 into 5 by 18. Timing is 14. Now if you calculate 9 2 times, 9 5 times, 2 7 times, 25 into 7, 175 meters. So distance is nothing but 175 meters. That's the length of the train. Length of the train is 175. So see here, length of the train is 175. Next, what about length of the platform, sir? You can go for D1 equal to S1 into T1, length of the train plus length of the platform, 15 into 25, which is 375. 15 into 25, we discussed shortcut already. Okay, ending with 5, 75 should be answered with 10 difference, so 375. Already length of the train is 175. Platform must be 200, so together 375. So option D, right? So very basic. You just try to divide. Observe the question. This is what adaptability is required. Okay, that's what companies are expecting. Sir, I know only C language. If you are fixing for that, no, companies don't encourage. Okay, you should be adaptive. You should be adaptive for situations. Sir, let's say the project is for Python. You can ask the company, sir, give me 1 week time to 15 days time. I'll learn and I'll go ahead with that project. Don't be confined. I know only Java. I'll do only projects related to Java. No, the problem. That's what. Okay, many of students are okay. Maybe rejected by the companies or they're sending them out because they are confined not to update their knowledge. We have to be ready to update. New technologies always will come every 5 years. You should be ready to adapt new technology and try to change things. Here, though, sir, I know time is distance by speed formula. Okay, but change the distance according to the question. Change the speed according to the question. That changing, if you do, you can, that mind thought process is required, then automatically you can learn any new technologies every time. Okay, there is slight variations. That's it. You should be ready for that. And if you are not ready, companies will send you out. I maybe already told you long back. In US, the scenario is like, you suppose they got a project for 6 months. Okay, they'll hire you people for that project. It's related to Python. Completed, then you have to relieve. It's not 3 years I'll work in the company. No, that project completed, you are gone. Next project is in Java. They'll again give notification. If you're good in Java, again you apply, come to the company, fine. When the project is completed, zero employees in the company, send out. All those people you send it out. Okay, that's how system will be. You should be ready for that. You should understand things. You should change as per the requirement. Next is a question here. A jogger running at 9 km per hour alongside a railway track. It is 240 meters ahead of the engine. Now this is what, see, so far we discussed train crossing a pole means train is exactly in front of the pole. A train is just near the pole. But now here they given a jogger running at 9 km per hour alongside railway track is 240 meters ahead of the engine of a 120-meter long train running at 45 km per hour in the same direction. In how much time will the train pass the jogger? This is what the question. Right, so it's all about only one parameter now, distance, speed and time. There are no two things. Previously, train crossing platform, man on the bridge, okay, different situations. Now only one, train crossing a jogger. 36 seconds, very good. So jogger, but situation here is, jogger is ahead of train, 240 meters ahead of the train. And jogger means, okay, moving, running, right? So there they mentioned speed 9 km per hour and 45, traveling in same direction. Distance between these two is 240. Train length is 120. Now time is distance by speed. What is the distance here, sir? Train crossing a man, sir. You said train crossing a man running is only length of the train. I agree. But initially here there is distance between train and man. So that also to be considered. That's what very important this question. 240 plus 120, 360. Now speed. Speed must be subtracted as they're traveling in same direction. This is kilometer per hour, but timing is in seconds. So again, you people need to divide and check it out. So 360 divided by 10, because this is 36 divided by 18, 2. 2 times will cancel, 2 into 5 is anyhow 10. So 360 divided by 10, which is 36 seconds. Train crossing a jogger. A jogger is ahead of the engine, 240 meters ahead of the engine. There is a gap. Okay, we have to just understand how that gap should be filled. Right. And CTS exam, what they given now, one of the question like, see this question if I want to put in advanced, this is okay, moderate level question. Now if I want to change this as advanced question, initially jogger is 240 meters ahead of the engine, train length is 120. Now question if you want advance, they'll ask you what is the time taken that jogger is 120 meter behind the engine, behind the train, not behind the engine, sorry, behind the train. Here what the question is last, what is the time taken by the train to pass the jogger, but instead they can change you, what is the time taken that jogger is 120 meter behind the train, then distance will be 120 plus 240 plus 120. 240 plus 120, train will reach the person that crossing, okay. But now train should be ahead of the jogger. A jogger is behind the train means that 120 extra required again. Jogger is behind the train means train is ahead of jogger. So train should be 120 meter ahead of jogger means again that 120 should be added. That's how in advanced questions they'll ask you. Okay, initially train is 120 meter behind so and so. Okay, after 30 seconds it is 120 meter ahead of so and so. What is the speed of the train? They can ask you questions like that. Behind the head, you try to understand both. they'll put in one question. Similar to this, they asked already in Cognizant one question like that. So once you understand this type of questions, you can able to solve that. Now this question, two stations A and B are 110 km apart on a straight line. One train starts at 7 a.m. and it travels towards B at 20 km per hour. Another train starts from B at 8 a.m. and travel towards A at a speed of 25 km per hour. Now, all things are good. Timings is in hours, distance is in kilometers, speed is in kilometer per hour. Conversion not a big deal. Now, question is at what time they will meet. Very, very important question. Listen. In question, if they not mention timings, I'll consider that train 1, train 2 both started at same time. But here they clearly mention one train is started at 7 a.m. Another train is started at 8 a.m. When now two different timings are given in the question, listen. When now two different timings are given in the question, we have to think about late time. 7 a.m., 8 a.m. Which is late time? 8 a.m. At 8 a.m., what is the situation you should analyze? So you have to work at 8 a.m. 8 a.m. When two different timings are not given, you consider both trains started at same time. You cannot apply the formula directly, sir. I know time is distance by speed. Here distance is, you said how much distance, sir? 110 kilometers is the distance. And you said, sir, opposite direction. One train is traveling with 20 km per hour, another one 25. This is 20, sir. This one is 25, sir. Now, can I apply? Can I apply? Time is distance by speed. Distance is 110. Speed is 25. 20 plus 25 plus because opposite direction you may climb that. But you cannot apply because timings are not same. Both are not active at 7 a.m. At 7 a.m. train 1 only active, train 2 not at active. We cannot apply the formula. Problem is that many may be thinking 110 divided by time is distance by speed applies for opposite direction adds it. No, sir. Problem here, both are not available at 7 a.m. Right? That's why I told you we have to realize the question at what time. Late one. Late time is here. By the time 8 a.m., this train 1 already reached 20 kilometers. Why 20 kilometers? What's the speed of that one? 20 km per hour. 20 kilometers in 1 hour. Now time is 8 a.m. By the time train 1 is at 20 kilometers per hour. Now what is the distance to be focused? 90 only. Now 8 a.m. both the trains are active. Now you can apply formula, my dear. Now sir, time is distance and speed. Yes, we apply. Both are active now. Distance is 90. Speeds opposite direction you add. Now one doubt everybody will get after discussing the basic questions is, sir, what about train 1 length, train 2 length? What about train 1 length? So for previous questions we discussed train 1 plus L2, train length plus distance and done. Now listen, here train 1, train 2 length not required. It required only when crossing. These two trains are in a gap. Now they have to come and meet. They're not crossing each other, my dear friend. The distance between them is 90. They have to come and meet only. Not crossing. So in fact, if suppose they ask when these two trains cross also, train lengths are 900 meters, 0.9 kilometers. Negligible compared to 110. Train lengths are now negligible compared to the distance between trains. If not given the question, that should we have to consider. Okay, generally they are asking train to meet only. Okay, so now 2 hours, sir. 2 hours from which time, my dear? 2 hours with respect to 8 a.m. Superb. So 8 a.m. plus 2 hours. What's the answer? What is the answer? 10 a.m. Now, recently in ESC exam, engineering service exam, listen, this is regular what we can find in any textbooks. So, advanced in this one, what they're asking is, at what distance from station A trains meet? At what distance from station B trains meet? At what time meeting is 10 a.m. Okay. Fine. Now, still they want to extend this question, ask some advanced means they'll ask you, at what distance from station A trains are meeting? At what distance from station B trains are meeting? Can you answer what distance? From station A and station B? Station A, which train is coming? Stationary, which train is coming? Train 1. Okay, so from distance from stationary is nothing but train 1. How much speed? How much time travel? How much is the speed of train 1? 20. How much time travel? 3 hours, not 2 hours, my dear. It started at what time? 7 a.m. Met at 10 a.m. So very important is that the meeting is happened at 10 a.m. Don't say 2 hours. Train 1 started at 7 a.m. So 20 into 3, 60 kilometers. So 60 kilometers from station A, trains met. Okay, trains meet each other at 60 kilometers from station A. If from B, don't say like 110 minus 60 is 50. Agreed. Answer is 50. I agree. 110 total. This is 60 means other one should be 50. Then only meeting will happen. But in exam, they'll ask only one among this. Then don't depend on the other factor. Directly what you can attack distance from station B is which one, which train, second train is moving from station B. Speed of second train is 25. Time taken 2 hours, which is nothing but 50 kilometers. From station B, it meant 50 kilometers. Station A is 60. In fact, this question, similar one we discussed like lines question, 870, 815 lines something, 870 back to front, front to back. But that question, this question if you see, that question two boys begin together, but this is not together. One at 7 a.m., other one at 8 a.m. This question both not started at same time. You may question is that this question we already solved. D1, D2 we already calculated in one of the question. Two boys total 817 lines. Okay, with 200 lines an hour, 150 lines an hour we discussed it. Yes, we discussed, but in that question both begin together. Both boys begin together, but this is not beginning together. Right. And this is, yeah, this we already solved 1320. Now this one question to give you the idea regarding same direction traveling. Two trains for Mumbai leave Delhi, both leaving. Timings is 10 a.m. and 10:30 a.m. My dear friend, when there are two different timings, we should work on late time. Late time here means 10:30. 10:30 a.m. You analyze what is happening. From Delhi, trains are moving to Mumbai. We don't want Delhi to Mumbai distance also. Don't worry, this is your Delhi. From Delhi, trains are leaving. So first train left at what time? 10 a.m. Now timing is, now what is the time? 10:30. Don't say 2:20. Don't see your watch and tell what's the time now. Okay. So in this question, we have to go for late time, 10:30. Half an hour completed. First train speed is what? 60 kilometers in 1 hour. Half an hour means 30 kilometers. So train 1, 30 kilometers. Train 2, here with 75 kilometers. But now starting. Now this is starting. Train 2, 75 kilometers per hour. Now first thing what you have to calculate is timing. What is the time taken to meet? What is the distance between them? 30. Both are traveling in same direction. Speeds must be subtracted. So 2 hours. They may ask you the question at what time they are going to meet. 12:30 p.m. they are going to meet. Because 2 hours. But what are they asked? Is it timing? They're asking what? Distance from Delhi. From Delhi, which trains are moving? Both the trains are moving from Delhi. You take any one sufficient. You take better. You take the second one, chasing one. Okay, chasing one travel 2 hours. So any train you can go for distance travel by train one or train two. Train two speed is 75. It travel 2 hours. 150 kilometers is your answer. You can go for D1. Sir, what about D1? D1 is speed 60. It travel 2.5 hours, my dear friend. It travel 2.5 hours. Train 1 travel 2.5 hours. Okay, 60 into 2.5. Right? Very good question. That's what Three objects are on screen, two trains traveling in opposite direction with 100 kilometers distance, 100 kilometers. Okay, train one moving in this direction with 50 kilometers per hour. Train two moving in this direction with 50 kilometers per hour. Both are traveling in opposite direction. Now, in between the two objects moving, now third one coming to picture, that flying. Here that fly starts from one of the train and okay going to another train and coming back to the first train. It's keep doing until those two trains collide or meet each other. So it's very simple. Distance is speed into. They're asking what the distance traveled by the fly. Okay, so distance is speed into time. Okay, the fly speed is nothing but 75. How much time it's traveled if you know? It's very simple. The time taken by the trains to meet each other, because the fly starts when train starts. The fly stopped when trains meet each other, collide each other. So the time taken by the trains to meet each other, time is distance by speed. Distance is 100. As both are traveling towards opposite direction, speeds must be added 1 hour. So that's why you have to take 1 hour. 75 kilometers. The distance traveled by the fly is nothing but 75 kilometers. So the job is done in 1 hour. So don't apply relative speed concept for three objects. We cannot apply for three objects at a time. We can apply only for two at a time. Any two at a time. We cannot go for three objects at a time. So that's why here we're applying only for two trains, train one and train two, which are traveling in opposite direction. Why speeds are added, sir? Opposite directions, so speeds are added. So I believe you understand problems related to trains concept. Okay, and relative speed together we discussed, right?